Okay, this is, I believe, tutorial 15, if it matters. So we're doing some Python, and we're going to be simulating rolling some die. And if we don't know what a die is, I'll just bring up a picture. So this time we're going to roll two die, okay? Or maybe you can think of it as rolling a die, recording the value, and then rolling another die and recording the value. All right, so maybe we're just rolling one die or two die at the same time. All right, it doesn't matter. Okay, so let's go ahead and bring up our editor here. Alright, so we're going to ask the question. Let's go and do a comment here. What is the probability of rolling let's say a 3 and a 3 and a 3 and a 2, let's say. Now, excuse me. Okay, so we're gonna roll two die, and we're gonna ask the question: what's the probability of getting a 3 and a 2? All right, a 3 and a 2. Okay. So first thing we're going to need to do here is import the random module, because we're going to need to generate some random numbers. And just like we did in the previous tutorial on rolling just one die, we'll go ahead and I don't know, we'll start with 1,000 here. How's that? The number of trials. Better say trials. Right, so rolling a die is considered to be a trial, and we get an unknown random number that comes up, so we'll define that as our random variable. Right. C equals 0, so we're going to need to keep up with some things here, count the number of times that this happens. Alright. What else do we need to keep up with? I don't know, we'll define another variable, outcome. Let's see, the outcome. Alright. Now we'll have to loop, keep looping, so we'll let C, that's the number of, right, that we're going to keep up with, and trials. Oops. Why does that capital S keep coming up? Alright, so here we go. Now we're going to go ahead and generate a random number between 1 through 6. We'll call this die number 1. Random, int, right, 1 through 6, and then we'll do another die. Now, like I said, we could be using one die, consider using one die, or we could be using two die at the same time. Doesn't matter. Okay, so let's see, we defined both of our dies here. Now we're going to need an if statement. Okay, we're going to need an if statement. Alright. Okay, if, now there's a couple different ways we can do this. If the first die is a 3, is equal to 3, and the second die is equal to a 2, now we're going to be sneaking in also an or statement, and I'll explain that to you here in just a second. We need to, let's put parentheses around that. Or the first die could be a 2, and the second die, the second die could be a 3. All right. Okay, so you see we throw two dice. We'll label one die number 1, the other die number 2. Well, on the first die we could get a 3, and on the second die we could get a 2. right? So that's one possibility. Or the first die could be a 2 and the second die could be a 3. All right. So we ask the question, what's the probability that a 3 and a 2 comes up? Now that's not in a particular order, right? You could get a 3 and a 2 or a 2 and a 3. Okay, so we got to keep those kind of things in mind. All right. Okay, so if this happens right here, we're going to go ahead and now count. And so our outcome, so out, C out, I don't know why I called it C, but it is. So our C outcome, okay, now we got to keep up with this now, right? So this is going to add 1 to the C outcome. So every time this happens, we're going to count that. Okay, so you should understand that. Okay, and then we got to keep up with this guy here, the number of trials. So C, we'll call that 1 there. All right. Okay, so that's basically it right there. And now what we're going to do is go ahead and print out the results on the screen. All right. Okay. And so we could do it this way. We could say, now x is our random variable. The probability that we get a 3, x is a 3, and x is equal to 2. Now you could probably say, you know, give the combinations up here, you know, x is a 3 and x is a 2, or I guess we could say, I don't know, we'll just say this. How's that? Right. And this is of course going to be an approximation. Okay. And then we'll say C out come. Now this is the total number. These are, we counted, this is going to be all the possibilities of our outcome over the total number of trials. Right, total number of trials. Wait a minute. I need to put a close parentheses there. Probability that we get a 3 and a 2. Okay. Alright, that all looks good, so let's run this thing and see what happens here. We're getting 0.057. Now, let's go down here and look at this theoretically. Okay. So on the first die, what's the probability of getting a 3? Well, it's 1 out of 6, right? And means multiply, so I'll do a multiplication. And then what's the probability we get a 2 on the second die? Well, it's still 1 out of 6. Or, okay, now plus means or, or what's the probability that the first die is a, now I think I said 3 here. What's the probability that the first die is a 2? Well, you get 1 over 6, right? And we'll do multiplication here. What's the probability that the second die is a 3? 1 over 6. Okay, so this is going to be 1 over 6 times 1 over 6 is 1 over 36 plus 1 over 6 times 1 over 6 is 1 over 36. So you can just consider that to be 2 over 36, which actually reduces down to 1 over 18. And then, so this is going to be approximately, now just think of this as an approximation sign, 0.055555 and repeating. Okay, so that means that our outcome here should be approaching, that's not it, actually. Well, I don't know how that got, right? So this number right here should be converging towards 0.0555, and actually it's pretty close there with just the 1,000 trials that we did. So let's actually add a 0 there and make that 10,000. Let's see if we can get a little bit closer. Can't assign an operator. Oh, yeah. Okay, let's get rid of that. So we're increasing the number of trials, which means that this should be converging towards the actual theoretical value. Right, so as you can see here, we got 0.05. So let's go ahead and add another 0 onto that. And that's actually a little bit further away from that number, but that's a possibility, I guess. Let's go ahead and add another 0. This should be pretty much 0.055 something. We're getting close to it. Yeah. See that 0.055. We're going to do this one more time, and then we'll call it quits on this one. So we could be rolling the die 3 times or 4 times or 5 times, right? Or 6 times. And actually, I think in the next tutorial, we're going to talk about being at the crap table, and you can either bet on black or red, and we're going to calculate what's the probability that like 10 reds in a row come up. So this is something I'd have to try. This is something I struggle with every time I go to the not the crap table, but the roulette wheel is what I meant to say. Don't know if you know anything about roulette, but we'll talk about it in the next tutorial since we're about on pretty much the same lines here. Alright, so how many are we doing here? How many trials? Let's see. Ooh, 10 million? Is that right? 10. So how long would it take you to roll 2 die 10 million times? I think you'd probably be there most of the week, month. Anyway, so as you can see here, 0.0555. So it's converging towards that theoretical value. Alright, so yeah, we're going to the roulette wheel on the next in the next video. Alright, so we're over here doing some Python programming for beginners basically, and having a good old time. And I'll see you in the next next tutorial. We're going to be heading to Vegas. Alright.